As a good engineer, you understand the benefits of simulation. The ability to carry out virtual tests on your product to gain knowledge of its performance in the real world before you make it is invaluable information during the design process. So why don't we all do it? Perhaps it's a lack of confidence, or you just don't feel that you have the knowledge to set up the simulations correctly. But guess what? With SolidWorks simulation, if you know how to set up a physical test, you know enough to set up a simulation. Take these handcuffs, for example. If asked to test the ultimate strength of a pair of handcuffs, you would probably simply put them in a tension testing machine and pull. But what if you didn't have the handcuffs, and all you have is the SolidWorks model? What now? What loads and restraints do you use? And what faces do you pick? For a novice user, there are just so many choices, it can be overwhelming. Rather than diving straight into the problem, let's use our knowledge of the physical test to guide the simulation. Just as in the physical test, let's include the grips of the testing machine. The beauty of working like this is that the loads and fixtures become very simple, and SolidWorks takes care of the rest. Once we have completed all the loads and restraints, we can hide the grips. A big advantage of using simulation is that you can slow everything down and see exactly what is happening. As the load increases, you can see the stress buildup in the fixed frame of the handcuffs. We can see the frame starting to bend until the teeth on the moving frame are pulled out of the ratchet mechanism and the handcuff is released. Although the frame still has some residual strength, our prisoner would be long gone. So how good was our simulation? Well, we took a pair of handcuffs down to the materials lab and put them in a tension testing machine. Just as in the virtual test, the handcuffs look good until, with the gentlest of pops, the teeth pull out at a load of 5 kilonewtons. If we continue to increase the load, the handcuff frame takes all of the load until the ultimate failure load. Comparing the physical test and simulation, we find excellent agreement for both the failure load and how the handcuffs fail. So with SolidWorks simulation, you can judge the impact of any design change you make on the overall performance of your product, ensuring that you achieve the best design possible. Although the simulation of your products might seem daunting at first, by using SolidWorks simulation and creating your virtual test the same way you would do a physical test, you too can see how your products will perform in the real world without having to build expensive and time-consuming prototypes. With the physical test, all you have at the end of the day are the broken parts and a results graph for one test case. But with the virtual test, you can look at every possible result and loading scenario time and time again, giving you a greater understanding of your product's performance so you can make good engineering and design decisions, making your products better and your customers more satisfied. To find out more, contact your local SolidWorks reseller to see how easily you can attain meaningful results with SolidWorks simulation, or explore this site further.